Hi, I'm Chris Perdue, the author of Prooftoys. In this video, I will demonstrate how you interact with the Prooftoys proof builder by using deduction to solve a small math problem. What you're looking at right now is an empty proof builder display with no steps. If you move the mouse into this empty area, you'll see some menus at the bottom, which is how you get things done in Prooftoys. So I'm going to start by using the command to consider a term to transform. Go down to that menu item, click, it prompts us. We'll enter the term x times x equals x, and we get a proof step. Now the consider command step is normally shortened for clarity and to reduce the clutter. But to be really explicit, let's show exactly what the step really looks like. For that, I'm going to select the entire step by going over to the step number and clicking on that. You can see the menus change once that's selected. And the command to show the full step is display in full in the edit menu. Click on that and we see that really any consider step is an equality or an equivalence, like in this case. That's an unusual kind of step, but it does help quite a bit with the clutter when you're reading it. So the first thing I'm going to do is to subtract x from both sides of this equation over here on the right. So I'll select the last x there. The subtracting from both sides is an algebra command. Go down to subtract from both sides. You can see the preview as you hover over any given step. It'll show you what the step really does because it actually does it there. We'll click on that. Now we get two more steps. One that shows the result of the subtraction. You can see how each side of the equation has an x subtracted. And then Prooftoys automatically looks around for potential simplifications to do and sees that the x minus x can simplify to 0. You can also get a little help with this kind of thing by hovering over the step number in a step. It'll show you dependencies. You can see that this one depends on step number 3, and you can see the focus of the activity, which is the x minus x part. Next thing I'm going to do is to use a form of the distributive law. So we'll take this term x times x minus x, select that, the menus change again. Laws like the distributive law are really based on facts, in this case that a times b minus b is equal to a minus 1 times b. We'll click on that and you see that x times x minus x becomes x minus 1 times x while the rest stays the same. Now you're starting to see some dots over on the left. In step 3 you have r of x, which is to say that x is a real number, and that implies the rest of the statement. It's an assumption. If two steps have the very same assumptions, the following one is just shown as a to again reduce clutter. But if you do move the mouse over to the ellipsis, the you can see the whole thing if you want to, or you can look up to the last step that doesn't have it. So this last step has a product of two quantities being equal to 0, and that happens to be equivalent to one or the other or both being equal to 0, and we have a fact for that as well. So we select that part, go down to the general menu, and we'll see that what we're looking for is that x minus 1 equals 0 or x equals 0. And that's almost a solution. So there's really two solutions. But to be in the proper form, instead of x minus 1 equals 0, we really want it to say x equals 1. So we'll select the 1, go to the algebra menu to add that to both sides. And now Prooftoys adds not just one, but 3 steps. One that has the addition of 1 on both sides of this equation. But then there's 2 automatically generated simplify steps. And if we go over and check where the simplifications are, we can see that it changes 0 plus 1 to 1, and it changes x minus 1 plus 1 to just x. And that is a solution. So let's take a look at the whole proof all at once. Down in this corner of the proof display, there's a handle that you can drag to make this window taller or shorter, so we'll open it up to see the whole thing. And just for fun, we'll save a copy of this worksheet. Now, when I save it, it's saved in the web browser persistently. You can come back anytime. You can turn your computer off, close the web browser, all those things, no problem. In fact, every time the proof changes, the worksheet is saved. So you can go to a different page. You can come back. It remembers what's being displayed in the proof builder and what the contents are. So we'll click on the worksheets button. We'll ask it to copy this to the name problem 1. And we're all set. Just one other little side remark. I hear that a lot of students like to start this problem by dividing both sides by x instead of subtracting x from both sides. And we can do that. Let me adjust the display a bit. Go back. Divide both sides by the x. And we get something like an answer immediately with the division step. Again, you can see the division by x on both sides. And 2 normalization steps that are sort of like simplification. However, you can also see, if you look carefully, that it adds a side condition that x is not equal to 0. And for this, to solve the problem properly, to cover both of the solutions, you need to do a little bit of analysis by cases, and that's a different story.